Well, thanks, Anka. And yeah, I will today start my presentation talking about the drivers, the motivation for new communication interfaces, and why standardization is clearly a desirable method. And then I'll also touch upon which standards could be relevant in this domain, and then speak in particular about the Danish experience with implementing one of these international standards for communication with renewable producers in Denmark. And then from this present day snapshot, then look towards the future. And so this presentation is also going to hopefully lead to a discussion, because this will be very much from my own perspective here in Denmark, and perhaps the choices that we've made about implementing grid codes and communication are different from where you are, and that maybe there can be you can share some of the experiences from your own particular region, and how they might be different from this Danish perspective. And yeah, Anka already introduced my background, but yeah, I do have a background and work experience with telecommunication systems in addition to power systems, and so that's why it was natural for me to take upon the role of looking at how grid codes can be specified to make it more clear, and hopefully going forward more efficient to communicate with many distributed devices in the future. And so I think the presentations earlier today are also leading up to this topic quite well, because Damien began by speaking about grid codes and how they're an important tool for system operators to create the conditions of observability and to as time goes on to move from passive to active networks, where the producers and other elements of the network are assets that can contribute to the efficient and safe operation of the network. And he mentioned in particular the smart grid communication, and that is what my presentation will be about in particular. That in that way it's rather narrow and focusing upon this particular piece of the puzzle about how to communicate between the system operator and in particular the distribution system operator with these many producers that they will be hosting and integrating in the near future. And then I'll also can relate this presentation to Paul. He already introduced some of the motivations for standardization, about how there are some of these problems with dealing with information that come up again and again, and there's no need to start from scratch. And that, in fact, when there are actors who are developing projects in many different regions, and that they also benefit from having a standardized way of interfacing with their local network operator. And so, as you're probably very familiar by now, that renewable energy is growing rapidly, and that the need for network reinforcement is certainly in place. The question is how much and how fast. And so I've taken these figures, excuse the Danish text, from the recently published map of the transmission bottlenecks and available capacity. And from the figure on the left, you can see the little lines, especially the red ones, are overloaded lines. And here, the time horizon is already in 4 years. And then all of the colored areas in Denmark, the darker, deeper color is the amount of overproduction, you could say, is the production capacity relative to the load. And so it's showing that, especially on the windy west coast, that there is a lot of areas where production is the dimensioning factor of networks already today. And then these figures are from a horizon only to 2025, but and you could also say that they're already conservative or underestimating the build out of especially solar power, and will only continue in the years towards 100% renewable electrified power system. And so clearly the need for optimizing the feed-in and using these assets, renewable energy production assets, efficiently is have strong economic drivers. And so at the same time, there is in the international arena, the EU has been leading initiatives to not have a one size fits all, but at least to have a more consistency across European countries, where there are some well-defined expectations about what a production unit should do. And so this is these are in effect that they have been rolling out kind of slowly but surely over the years, and it's not a revolution as such, but it does provide a framework for harmonizing on an international level, so that renewable energy developers don't have to start from scratch if they go to a new country, but do have some familiarity with the kind of codes that that they'll be met with. And so I have taken a quote, for example, regarding this exchange of information between the producers and their network operator. And it says no more than no less than and information should be exchanged. And the TSO will define which information will be in real time. And so in Denmark, this has resulted in an expectation that in the coming years, every production unit above 1.5 megawatts will have a real-time online measurements that will be sent to their local distribution operator if they're DSO connected, and then further forwarded on to the TSO. And so this is not what's done today, or at least the previously to give some background about how the evolution is of communication to DER is taking place. That until now, the network operators had the SCADA system that was taking measurements in their stations, so they would measure the current and voltage at the station, and that was an adequate snapshot, but there was no possibility for control in any way. It was a one-way connection, and so that in terms of optimizing the network capacity, that the absence of control is not optimal. That you can't control the voltage or change set point values for these local controllers, and there is no feasibility for any sort of closed loop or low latency type of control, and so to really introduce realize the full potential of controlling these distributed assets, then the reliability and fault tolerance of these communication systems is also a factor that can be increasing the value of these and hosting capacity for renewable assets. And so what we're seeing in Denmark now for distributed energy resources, here I've illustrated with a wind turbine, but it's actually more commonly combined heat and power plants, the smaller local combined heat and power plants. That there is a need for more measurements, not only the current that is coming out of this device, but what about the state of a breaker? Is a synchronous generator synchronized or not? That you can't necessarily know that only by taking measurements in the station. And as a result of that, network operators place their own equipment out on the site of their customer to measure the state of breakers, for example, in addition to the voltage and current. And so sometimes these these control systems are realized with hardwired physical signals from key components, analog values. Sometimes there is a serial connection to the local process controller, so that there is the foundations for two-way communication. And yet this is still a process that takes quite a bit of engineering time to figure how these communication systems will interface, because they will be all different to some extent. And that's really where standardization is necessary to provide this productivity necessary to integrate many more of these type of systems. And also another feature of the control systems and measurement systems in place today is that they will use often a wireless network, and there are often, because it's I'm speaking in a general case, that typically the DSO's own equipment, that they will have a network security that is kind of out of the box and kind of you could say fixed, a VPN that maybe would require some manual intervention, manual setup, and it's not highly automated. And so this is I was drawing that from the DSO perspective, from the perspective of a combined heat and power plant. And again, excuse the Danish labels, but a combined heat and power plant is a rather complex entity with both energy production and energy consuming units. And they may have a need to interface with many partners besides the local distribution company, because there'll be some commercial actors who are selling that power, and there could even be different commercial actors controlling different units in a combined heat and power plant, if one is a consumption unit and one is a generating unit. And so this current spaghetti of communication connections is both a headache to establish and maintain, but especially with respect to security is quite it's quite difficult to have an audit to see who has access to what and where potential security vulnerabilities lie. And that's why it has been some years. These figures are from a project called CHPCAM, which was a successful Danish demonstration project, where we created a proof of concept, so to speak, for this illustrated control and communication system that simplified external access to distributed energy resources, so that there was one gateway, one port of entry, where there was a transparent access control list, who can do what and when. If someone changes their balanced responsible party, then they know exactly where to go in the setup file to change out one name and IP address with another, change the keys to and do so in a way that that both of the power plants can reuse the same interface with different external actors, and also from the motivation from the side of the balance responsible and other and network operators, that they would also benefit from having the same language and protocols to speak to all of their units in their fleet. And so this from the DSO's perspective, which will be my current main point of view from Dansk Energi, that they certainly see an advantage in not having to maintain their own RTUs placed out and about in their network. That they would like, you could say, a software only kind of a connection without any hardware, and then also banking on the fact that any industrial plant will have some kind of internet connection, that you don't need to create another completely separate communication network for this type of traffic. That what you really need is encryption. You need secure. You need to encrypt the content but moving data across an IP network doesn't have to be a custom solution. And so these types of connections are actually, as you could say, accurately describes the way that transmission connected plants are interfaced with a TSO today. Maybe with the exception of the public IP network, there would be for the largest units a private network, but otherwise there are that this is in place for TSOs, and so we want to replicate these efficiencies in the DSO domain. And so as Paul mentioned in his presentation, the attractive standards, international standards, are very attractive for harnessing this kind of industry collaboration, because they don't need to start from scratch every time there's a new plant who is connecting. Which protocol should we use this time? That there is no need to revisit such fundamental questions every time. And also as network operators and energy producers are typically customers of some kind of automation consultants or vendors, and by agreeing upon well-known standards, it also gives them more choice between who is going to be their supplier and where are they going to get the components that are necessary to build a system. Because really, it's, as far as my point of view, it's when you're talking about complex systems with many components that you don't really want to work with black boxes that are closed and unknown. You want to as much as possible have these standard interfaces, and that is also key to automating the process of how do you bring online a new plant to test that all of the signals are in place, and to also later validate that they continue to work year after year. And so this so if the drivers for agreeing upon something are so strong, then the next question becomes, well, then what are we waiting for? Why don't we just agree upon a standard and get implementing? And I think this is a common quote about standardization, is that unfortunately it's not so easy, because there are numerous standards that could perhaps do the job. And so I'm going to reveal some of the considerations that were in place in Denmark, and perhaps you in the audience, your own circumstances, or you can recognize some of these considerations, but perhaps the decisions that were made were conclusions were different. So yeah, this is my own you could say personal pros and cons, and if when I get to the challenges, how our conclusion from this analysis phase didn't lead to a smooth implementation phase, it could be that there is room for different routes or different conclusions and different implementations. But to look at the standards, there are industrial automation and remote control is taking place today. So why isn't what's done today good enough? Why can't we simply build upon what is known to work and bring in the advantages of having the centralized security, for example, for a given power plant? And there is an IEC standard that is widely used, known as 104. And that even new installations today are using this standard, despite, or is it because of the fact that it is many years old and grows out of serial point-to-point communication that defines a way to send those those serial packages across the internet. so that you no longer have to be right next to the machine, but otherwise it is very recognizable. And the shortcomings are quite grave, you might say, regarding security, that there isn't really, as part of this particular protocol, a security mechanism. So you have to build that externally upon that. And then you're back to the question, okay, but then how do I make sure that it's the same everywhere? That everybody does it the same way. The other shortcoming of this particular protocol is that it defines how to move data from one place to another, but it doesn't define what that data is. And so again, you're back, you could say, into the custom and expensive consulting hours of defining a table. This address has this meaning, and it could potentially be different for every single plant, which there's no real need to have that uncertainty when it is possible to define data in larger clumps and larger units, and that's what the data model can give. Outside of the energy domain, there is industrial automation of complex factories, for example, that have many different machines that need to work together and talk together. Is energy utility just a comparable environment that is spread out geographically, but perhaps has the same complexity of interactions? Yet it's possible that protocols from this domain could be applied into the energy domain, but it, as far as I know from my own observations, that hasn't really been happening. And so another possible source of standards could be in North America. There is a so-called DNP in the third edition that is being used, but it's in the North America, and why it hasn't gained traction in Europe, I can't answer for sure, but I can observe that the IEEE, despite the IEEE's backing, it isn't really doesn't have momentum here in the European context. But what does have momentum is 68150. Which has the backing of the IEC, and this certainly has some advantages going for it. If you're talking about what is the point of departure, where is it now that it's positioned for these new applications, it can be seen as attractive, and it is in use by many utilities for their own equipment, for controlling equipment that is in their own substations. So it gives a certain familiarity, and that's maybe one of the explanations for why distribution companies, at least in Denmark, haven't been so quick about rolling out 61850 for communication with production units, is that actually they don't use it themselves for their stations. That it's perhaps it's more of a transmission station communication, and distribution operators, when they don't have so much automation equipment themselves, then not even this standard from their own domain has been is very familiar. But it's interesting because besides defining packets of communication, data packets to be sent across the wire, it in fact is broader, and it defines an entire tool chain, a workflow with different tools that allow you to set up, to configure, to have configuration management, and also it doesn't match. At least it didn't previously match closely with the SIM standard that has been fixed, because IEC and the same technical committee is behind SIM, as Paul touched upon, which is used to exchange data for models and in an offline kind of environment. That 61850 has a role in the online and real-time environment, and it is possible to map the definition of objects back and forth between them. And but one of the limitations of 61850 as it is today in the state of the art of this in this snapshot is that while it is in many organizations, many utilities used within them, that it is very rarely used between them to exchange information, in this case with the production customers. And but it could be that there are extensions models defined specifically for DER, wind turbines, PV, combined heat and power plants, you name it. And there is also defined, you don't need to guess about the best way to implement security, that it's also defined in a standard so that you can ensure the communication between organizations also takes place in a secure manner with authenticating who it is you're talking to out there. And it builds upon existing internet standards and implementations. So there's nothing really mystical about how this security should be provided. It's the same that your bank uses today. And so on the basis of these advantages and the needs of the Danish distribution system or Danish power system, that that on the back of these EU mandate to introduce communication out to distributed units, and then to facilitate the collaboration between the distribution networks where the majority of this renewable production is located, and the transmission system, which of course at the end of the day has the responsibility for the secure operation of the network. Then was agreed upon to work towards the architecture that's illustrated here, and the features of this architecture. I may find is that already now the first it's only brand new large transmission connected power plants that are mandated to have 61850 today. The older transmission connected power plants will be required to convert to this protocol in the coming years. That the TSO, it has taken some investment or elbow grease to get their gateway working to receive 61850 data alongside of the other data sources that their SCADA system works with. But that at least at the beginning of this year was up and running. So that we can say is taking place now. And the same requirements will propagate down to smaller units, all the way down to 1.5 megawatts. That in the future, all 1.5 megawatts and larger units will be expected to essentially communicate in the same way, but they will not be communicating directly with the transmission operator. They will be communicating with their local distribution company, and the distribution company will propagate that data through a so-called proxy gateway, which simply mirrors the data from many distributed units up to a single interface that the transmission operator can use, and also the distribution companies themselves will use the same server for importing this data from observability of their network. And this architecture also allows the transmission operator to have two-way communication if they want to send commands or change the set points of particular units that are perhaps providing ancillary services. That using this architecture, the DSO will also have full visibility of what changes are being done to their to the units in their networks, and perhaps, if necessary, overriding them if there are local considerations that are endangering the security of their own network. And then I've also drawn in gray it's almost like a backdoor. This is actually the existing communication channel, is a so-called TASA2, that is another IEC protocol that is for control room to control room data exchange. And that is envisioned to continue to exist in parallel, so that the measurements that are taken by the DSO themselves of their network will continue to use this existing communication channel with the DSO. And perhaps in the long term, all of the communication between control rooms could also be packed into the data models of 61850. But actually, in the near term, it's actually the opposite. That because this is a requirement for the future, that at present, then TASA 2, this existing control room to control room protocol, will be used also for the DER data. And so that yeah, I have sketched out the vision, so to speak. Excuse me, the plans that have been made, and so now we are in the process of working towards realizing this vision, these plans, and despite using these international standards that have been rather mature, at least in the controlling stations domain, that we found that even though yes, even though the components each and of themselves is mature, that we are using them in a new way, and that it turns out that there are some of these details that have been giving some friction, if you will, in preventing a smooth rollout of this new communication system. And yeah, it's our observation that the existing vendors that the distribution companies in Denmark are using for their SCADA equipment, that they are not quite ready for importing or working with 61850 data. That it has been on their product roadmap, and they are rolling out now, but it has been very very new, that it is the latest, and not all of them have come up to support these protocols for importing into the existing SCADA system. But that is say it right now being fixed. But the proxy gateway component that should collect data from many units and send it onward, that's a function that is common inside of a station when you have many breakers and measurement units, and you want to have a single gateway or port to communicate to. In this case of having a wide area network collecting data across a large geography and having a proxy, there isn't an off-the-shelf product ready to have that functionality. What's different is the security, especially that when you need to have authentication and encryption of every single link that you're aggregating, and with the need for automating all of the handling of the encryption keys and such. That while the protocol for automated renewal of encryption keys, that they do exist, but putting it all together, there is an integration task which hasn't really taken place. At least the solutions, such as they exist, are characterized by being from independent vendors and consultants who have difficulty in providing the long-term service and an extremely high mission-critical reliability that the distribution utilities expect. And And to me, it kind of illustrates somewhat of a dilemma, because on the one hand, taking these existing components and filling in these missing pieces to create a component to fit into this system, it's when it is offered by very small independent software houses, it does indicate that you don't need to have a whole building full of engineers working for years and years to make this component. That it is within reach. But at the same time, when you have these needs for long-term support, then getting from a consultant or independent small vendor is not considered attractive. And open source is one of the possibilities for bridging that gap if the source code for such a solution was part of the product, so that in that way the long-term support was guaranteed.
Yep, it's 903316.
Excuse me?
891.
I think someone didn't mute their microphone. And yeah, this is a theme I'll get back to about perhaps the international standards from the IEC and the open source community of having implementations that are freely available to be used and improved are perhaps the missing link to allowing this deep integration of controllable units across the power system. And yeah, as I mentioned, the managing of security keys, if you don't have so many, like the transmission operator has up to 30 large-scale power plants, they can afford to have IT personnel to handle those 30 encryption files. But if you have 30,000 and you're also a distribution utility without a dedicated IT personnel, that you need an automation system that can scale. And as I said, this doesn't need to be invented. That has been defined, and there are the first of these certificate authorities that have implemented it. But when you want a certificate authority for these encryption infrastructure that also has a strong anchoring in Denmark, that you can connect all of these identities to a particular company registration number, tax number, and an address. That then there are more requirements than only having this particular automated key renewal. And so in Denmark there is a encryption key infrastructure provider that cooperates with the tax authorities and has the highest level of credibility in Denmark, which we would prefer to use because it's used in the financial sector, among others. That they don't yet have the machine-to-machine capabilities that some of these international ones have, and so they said that it's coming, but we would rather not use an international key provider, because perhaps their links to validating the identities locally is not as strong as we would like. And finally, another detail that has emerged, which applies both to especially to the customers themselves, is about how to differentiate access to these signals and to the measurements and control signals, because at the moment there are so-called role-based access controls, so that there are different groups of users who can have different permissions, but to be able to specify signal by signal who can do what, that isn't a standard feature yet, and that would be required if the same interface was used by a balance responsible who was optimizing the production, and a distribution utility who perhaps would be limited to reading measurements and maybe having an emergency stop signal if that was part of their connection agreement. Another issue is that 61850 has been revised recently. It's been improved. It's not a problem as such, but it does indicate that it's not rock solid and mature like 104 or Modbus. That we can expect that this version 2 will be stable for a very long time. But if you have a product now, you might need to closely read the data sheet. Does it implement then the previous version or this new version? And finally, one of the persistent challenges in deploying this new technology is the DSOs have a very low risk tolerance in their operations. That they have you could call it quite limited control handles in their existing network, but they have expectations of very high reliability from the start, and it is a different attitude to managing a large number of distributed units, where perhaps the reliability of each individual one is less, but as a whole, that they have can still perform and provide valuable services. And so going forward, that we frankly have delayed the rollout of this requirement for 61850. That at the transmission level, that they have been able to show this proof of concept that it can be done, at least if you have the resources of hundreds of megawatts at your disposal. And now the task is to scale it down while scaling down in the size of each individual unit and scaling up in the number of units. And so we're expecting now in 2024 that will be when the requirement for implementing this is fully rolled out. And from our observations around Europe about how other countries are dealing with the same EU framework, that it seems that Denmark has gone our own way, so to speak, in relying alone on 61850. That other countries have included it as an option, but have in the grid codes, at the level of grid codes, given other options as well. And so that would obviously put some burden on either the system operator to speak different protocols to different units, or on developers who would need to implement different, even if every particular utility had their own requirements, that they would then need to deal with a diversity of communication interfaces. And so here, then, in closing, I'd like to highlight what I see as a potential route to dealing with some of these challenges, and that is an open source project that it is very much in its early days. So that it's there's much work that remains to be done, but there is a open source project that has the backing of the Linux Foundation, that is a universal general purpose protocol converter. But when 61850 is one of the protocols that it can speak, by having it on both sides, so to speak, of this conversion, that you can aggregate and then provide this proxy gateway functionality. And that this acts as in best open source methodology, acts by gathering together diverse projects under one hat and making them work together, and certainly has the potential to fill this role of the proxy gateway that we're missing. But as yet, it is quite very much a development project, and doesn't have the track record to just roll out, but indeed requires some effort to get it up to the needs of the Danish distribution authorities. And so if I if I may be a bit use some exclamation points and be activist, I think that that the motivation for standards is quite obvious, and that the candidates are there. That at least here in Northern Europe there is no better alternative than 61850, and that there are some starting open implementations to act as a reference, but they're not hardened and really deployed on a wide scale. But as we've seen in many other domains, that the open source development methodology of collaboration as opposed to competition, especially when many different organizations need to agree upon something, that having a freely available and highly reliable implementation is one of the means that that the IEC, when they print a standard, that they rely upon this you could say monopoly environment in some cases, that someone can force the implementation, where here in this more diverse DER, where there are many different commercial developers who have to exchange data with many other external parties, the DSO just being one of them, that there is a more competitive environment where they need to make a more they can't simply mandating such a communication protocol is a slow way of making things happen. And so that's those are my comments for today. I wonder if I have provoked any reactions among the audience.
Thank you very much, Philip. Thank you for a very comprehensive presentation. And let's see if there are any questions from the audience.
Hi, Philip.
Yeah, Asheria, please.
In the standard, you showed a diagram where the DRs were connected by the standard, like they were communicating with something, and then there was a TSO block and a TSO block with the gray. This one, yeah.
Mm-hmm.
And so is the TSO SCADA and the DSO SCADA exchanging data, or that's something that needs to be explored because the arrow isn't clear?
With each other?
Yes.
You're referring to this one?
Yeah.
Yes, that happens today. The data that's exchanged is station data, the flows in and out of key buses, for example. That's the so-called TASA2, and it's a protocol that's it's extendable, so you could define more data points to cover these new units. But the drawback is that there isn't a data model. So in that way, it's comparable to 104. That there isn't, as far as I know, the same kind of rich template of data model. That it would require quite a bit of coordination to say, this week we have a new unit and it has this number and it has these capabilities, and that there'll be a potential for a lot of manual interventions, which doesn't really work when it's such a rapid build out of very many units.
Okay, thank you. I can see that there are two other hands raised.
I had one question.
Yeah, if you have one more, Asheria, please.
Philip also mentioned that the DSOs would like to use the existing RTUs, and all of this communication is only subjected to the DERs 1.5 megawatts and above, or also smaller units.
Yeah, the main context for this, you could say, rich two-way communication is 1.5 megawatts and above, and that and yeah, when I mentioned about the RTUs that are in use today, that it is an expense, and regarding both acquiring these boxes and especially maintaining them over time, that is really an unnecessary expense when you when you say that they are a hardware box, but their function is a software of just taking some data in and changing it and sending it onward.
Okay. Do you have more, Ashwarya?
Yeah.
Okay, so next is Kaushik, who has a question to you, Philip.
Yeah, it's more on following up on Ashwarya on this slide. Is it real-time data exchange what you have there?
Well, yes, that's the intention. If I remember, it has looking at a 3-second intervals or latency. But yeah, it is intended for relatively high frequency updates of measurements.
And does this mean only at the substation for the connection between TSO DSO, or it's also required? You can also provide, or they can ask for data at the lower substations if they want.
Yeah, the TSO is entitled to information about the production units, about the distribution network itself, that they have more limited observability. But among the production units, then they can look at what is the power factor that's in operation at this moment, the instantaneous power production, and the control modes if they're in have a frequency group and so on.
Okay, and what might be the DSO? What can they ask from the TSO? Do you know what kind of data?
The DSO from it, that's a good question. That one of the things that will be interesting or important for DSOs to know is about the ancillary services. That every hour there can be different providers of frequency reserves, and the DSO would like to know when it is units in their own network that are providing such ancillary services. They'd like to know in advance. So that would be a case of market communication, really, because these are services that are bought and sold on the market. That the DSO would has an interest in following along who's being paid for these reserve markets, so that they can set their expectations when they have a worst case kind of looking at the security of their network. Then they suddenly have to see, is it the worst case when there's also a under frequency event, since there will be a different frequency response.
Thank you very much, Philip. I think that was very helpful.
Thank you. And it is time for one more question. It is oh, it disappeared. It was Subham. Yeah, Subham Saho. Can you please
Yes.
turn
Yes.
on
Hi.
your camera, maybe, so we can also see some faces?
Oh, okay. Yeah, sure. I can do that. Can you see me?
Yes, thank you.
Yes. Hi, Philip, and I am from Aalborg University. And thanks for a very nice presentation. So my question is pretty much more about the security aspects, because you were detailing more about the communication architectures, and I have been working on security for power-tronic systems. So could you give us some, some examples where you feel that which sector is the most vulnerable one? Because, based on the past examples or based on the past incidents that has happened in the power grid, communication can be, a way to penetrate into the system, but the final target is something else, really, usually the SCADA layer. So where do you see the vulnerable areas as compared to wind power systems, for this matter, right now?
Yeah, that's an important issue of that one of the areas of discussion that, if I can hop back to this previous work, is that that has been identified that these balance responsible, that they are a kind of a key player that's a bit in the background or underappreciated, but in fact, balance responsible, one of them may control gigawatts of production at any one time, and and that they are also have a intimate connection into the processes of many distributed units, and so that was that looking at the current state of the art today, where a small combined heat and power plant, plant, that they would have what's in Danish called the maskinmester, that there would be a technician on site who can make sure that the valves are tuned and inspects things visually, but doesn't have the expertise of in the IT domain to be expected to be able to monitor, also monitoring their firewall or looking at the logs of their different connections, and especially if their different actors have different wireless units, you might easily forget that there's a blinking LED in the back there that is in fact an unmonitored external connection. And so that was one of the motivations for recommending this architecture, is to have a centralized point of contact, so that there was well-known, well-documented access control into these many distributed power plants.
Okay, all right. How do you feel about distributed communication in this case? Do you think that will provide more robustness as compared to a centralized way of communicating to the generators?
Well, that I mean, I'm sure you know, the internet was built for being robust. With the alternative routes, if any one particular router is down, and so for the parts of the energy system that communicate with the transmission connection and between control rooms, that those are also today running on closed private networks, and that will also continue. That is the, you could say, gold standard for privacy and resilience to denial of service attacks. But it is when you get out to these smaller units that you can't really justify such gold-plated solution into every little wind turbine, and that yeah, just like as in cases of reliability studies, that when you have a wind turbine that fails, that it doesn't necessarily pose a threat to the whole system, because each one itself is so small, and as long as they all don't fail, and that can be comparable with the communication system, that if one of them is compromised, then that's a problem for the owner, but it's not a problem for the system.
Okay. Thanks so much.
Okay,
well,
thank you. I also have a very short question, Philip. We can understand that there is an increasing challenge regarding the cyber security in the future, and there are all these protocols. Can you elaborate how fast and how often these protocols should be revised, and which is typically a time frame for that?
I don't think I can say in detail that, but I can say that that one of the main issues with dealing with a heterogeneous network, where there's many devices that have been installed at many different points in time, is backwards compatibility. That it'll be difficult to go out to every unit and upgrade them. And so you want to, for practical purposes, to continue working with older encryption methods, even though that they're, at some point you need to acknowledge that they are no longer adequate for the threats that are out there. And so at the moment, on the forefront of standards development, there is a movement towards getting ready for the so-called quantum encryption. That is you could say revolutionary methods for encrypting communication that are fundamentally different. Also, that these quantum tools potentially cannot make the existing methods obsolete, and so that's why they're preparing for a break where that when a communication link is established, that there is a negotiation between what are your capabilities, what are my capabilities, and then we find the highest common denominator, and that's how to keep older devices with serviceable software is that at some level there's no way of getting around that someone is going to be responsible for going out there and upgrading the firmware or replacing the entire control system. As a software developer myself, I think it's a shame if good hardware is thrown in the garbage because of a lack of software. But that does happen, and yeah, with a modular system, you can perhaps limit the what needs to be changed or often updated to being a smaller part of a larger system.
Okay, thank you one more time, Philip, for a